Question 12, Part A. The diagram shows points A, 1, 0, B, 2, 4, and C, 6, 1. The point D lies on BC such that AD is perpendicular to BC. Part 1. Show that the equation of BC is 3x plus 4y minus 22 equals 0. To find the equation of a line, first we need to find the gradient or the slope of that line, and then using any known point on that line, we can apply the point gradient formula to find the equation of that line and then rearrange that equation into any desired form. In this case, we want the equation in general form. I've sketched interval BC here for reference. Here's point B with coordinates 2, 4, and point C with coordinates 6, 1. And the gradient of a line is found by finding the change in y and then dividing that by the change in x. Now the change in y, starting at 4, ending at 1, the change in y is -3. The change in x, starting at 2, ending at 6, the change in x is 4. Using the 2-point formula, that's y2 minus y1 divided by x2 minus x1. So we get -3 divided by 4, which equals -3 over 4. Now the point B, 2, 4, lies on BC. Hence, using the point gradient formula, that is y minus y1 is equal to m times x minus x1 in brackets, we get y minus 4 is equal to -3 over 4 times x minus 2 in brackets. Now we can eliminate this denominator here, this denominator of 4, by taking it over to the other side, so multiplying the y and the -4 by 4, we get 4y minus 16 is equal to -3 times x minus 2 in brackets. Expanding the brackets on the right hand side, we get 4y minus 16 is equal to -3x plus 6. Moving all terms over to the left hand side, so we have a 0 on the right hand side, and combining like terms where required, we get 3x plus 4y minus 22 equals 0, which represents the equation of BC. Part 2. Using the perpendicular distance of a point from a line formula, D equals the absolute value of ax1 plus by1 plus c over the square root of a squared plus b squared, find the length of AD. Using the perpendicular distance formula with the equation that we found in part 1, that is 3x plus 4y minus 22 equals 0, the distance D of point A from that line is given by the absolute value of 3 times x1 plus 4 times y1 minus 22 over the square root of 3 squared plus 4 squared, where x1 is equal to 1 and y1 is equal to 0. These represent the coordinates of the point A. So substituting those values into the perpendicular distance formula, we get the distance D is equal to the absolute value of 3 times 1 plus 4 times 0 minus 22 all over 5, which gives us the absolute value of -19 divided by 5, which equals 19 over 5 or 3.8 in decimal. Part 3. Hence or otherwise, find the area of triangle ABC. To find the area of a triangle, we use the formula half times the base times its perpendicular height. Now in this case, the interval BC is the base of triangle ABC and AD is its perpendicular height. To find the length of BC, we need to use the distance formula, that is the square root of x2 minus x1 in brackets squared plus y2 minus y1 in brackets squared, which is based on Pythagoras' theorem. In this case, BC is equal to the square root of 6 minus 2 in brackets squared plus 1 minus 4 in brackets squared, which gives us 5 units. So to find the area of triangle ABC, it's half times the base times the height. Now the height, 19 over 5, we found in part 2. Multiplying all that together, we get 19 over 2 square units.